Hi everybody, this is Mr. Yeoman again, and today what I want to discuss with you is how to calculate theoretical yield. So this is going to be the final part of your final exam where you have calculated out how much of the reactants you're going to need to use in order to make a certain amount of products. So on the screen I have the simple problem that I showed to you in a previous video where we need to get 1.7 grams of sodium acetate. And from that, we end up going through and looking at the molar mass of sodium acetate, the mole ratio of sodium acetate. I don't have the balanced equation on here, but since we've done that in previous work, if you need a review on that, please look at one of the previous videos. And then I have the molarity of the acetic acid, which again, if you need a review on that, take a look at the video on molarity. And so we should be getting 1.7 grams. We said that we needed to use 25 milliliters of acetic acid in order to get 1.7 grams. So that 1.7 grams is really what we are looking for in regards to, sorry about that, in regards to the expected amount. Okay, so that's really what we care about right here. And so when I'm talking about theoretical yield, what that is really referring to is how much we are supposed to, how much are we supposed to end up receiving versus how much do we actually get. So I think we've all been to that point where we know that we're supposed to make a certain amount of something, but you never actually get the amount that you're wanting. So imagine that you're baking cookies and you make enough dough for a certain number of cookies, but maybe some of the cookies burn, so you don't actually end up with a dozen, or whatever the scenario is. So theoretical yield is calculated by taking the actual amount that you end up getting from the lab and dividing it by your expected. So in this case, our expected amount should be 1.7 grams. Now that's fine, except when it gets down to it, we're not actually going to probably have 1.7 grams for a variety of reasons, maybe slight measurement errors, partly just because not all of the reactants will react in the amount of time that you give it. We can talk about all of the different variables that would end up affecting that. But what we really need to do is find out how much did we actually produce. So I was supposed to produce 1.7 grams. Well, when I get this, my sodium acetate is going to be dissolved in water, so I'm going to have to get that out. So I'm going to have to boil off the extra water, and I'll be left with a crystal inside of my beaker after I evaporate off all the water. And that's fine as long as I know how much my beaker weighed before. Then I can subtract the weight of the beaker before from the weight of the beaker now, so that I know how much the sodium acetate weighs. So let's just pretend for a second that I've done that. Okay, I've gone into the lab. I know that I'm supposed to get 1.7 grams of sodium acetate. Okay, so I'm supposed to have 1.7 grams of sodium acetate, but I don't actually get this, and you won't know this until you complete your lab, because you won't have that number. So let's say that I did all that, I evaporated off all of my extra water, I put that on the scale, and it came up with I actually only received 1.4 grams of sodium acetate. All right, so all I have to do is just divide this out. And when I do that, I take 1.4 divided by 1.7, and I receive 0.82, which is fine because that'll be the correct number of significant figures. So 0.82, which is the same as 82%. So in this situation, if the number that I got was 1.4 grams, if that's what I actually measured that I got out of this, then I got 82% of the amount of sodium acetate that I was supposed to get. Very simple, very straightforward. Something that you can add on to the end there. It will not take a whole lot of time, so you should be able to do that at the end of the period during your finals time. Okay, so just make sure you get that into your lab report and show where you're getting that information from. So it's a very simple mathematical problem, but it is an important one because otherwise you're just assuming that you're getting 1.7 grams and you may not actually do that. And that is important for people who are running businesses because if they're trying to produce a certain amount of product, then they may need to know that, okay, maybe each time I'm only getting 80% of what I'm supposed to, so I need to up the amount of reactants that I need to purchase. So a variety of situations where you would need to know that theoretical yield, or I'm sorry, your percent yield in here. So hopefully that helps you out. If you have any further questions, please let me know. Thank you.